Hello mates. In this video we will try to decode or to say to learn some of the nuances that we do with the Titanic dataset, since it is a very uh, basic dataset that we have to encounter while we are doing machine learning, or when we are starting to begin with the machine learning. So especially I would like to talk about this image first, because this gives me enough inspiration that there are real people involved in this data set. So why not to have an image and make it more into it. Okay, so we start with some import numpy pandas c1, and then we have this image. In this image, I might describe like I have just kept it somewhere, and I'm giving it some width to like display. I've tried different combination, but this width was like very good looking. Now my way of writing data frame is like df stands for data frame, then underscore, and the data frame actually the which you want to give. Why do it? Because like it makes, at least for me, like it makes more sense to write in this way, because like at later point of time I know all the data frame variable like are defined by df underscore, so I can quickly have a look, find or search or whatever. Okay, so you see I have downloaded the Titanic dataset CSV, and then I'm reading it using the pandas CSV method that we have. It has 838 91 rows and 12. So this is the very first thing that we want to know, like about data frame, that how many rows are there, like how many people are we talking about. So roughly it has 891 and 12 columns are there. What are those features? Okay, columns are sometimes also abbreviated as features, labels. So better like we know. Then we have, if you look at the data types, so once we have how many rows are there, we possibly want to know what is the schema of the columns. We have 12 tables or 12 columns. Now we want to know. So you see we have something called object. Object is like, I would say, it's a string, and then we have integer id, passenger id. It makes sense, it should be integer. Survived is an integer, so means like I think it's, well, it should be 0 or 1. P class, if it is an integer, means like there would be like 1 2 3 4 5 6 till 8 or 10 like classes. Name, we know it should be string. Here if it is object, this sex, it means there would be male or female gender. Then we have this sib_sp, it is integer. I'm not much aware of this, how it looks. Parch, I also don't know. Ticket seems as if this should be string, it's okay. Fair should of course be in digits with certain precision, so it should be a float. Then we have a cabin, maybe something, we will see about it. Okay, so after doing this, like one thing you notice, like now we are aware of the columns, roughly aware. So first we got to know the how many rows are there, then we got to know how many columns were there, column count were there. Now we are getting to know how many like what is the data type. So what typically we are trying to do here, like is trying to understand like why this is why this data set like is like important. So generally, like when you will start with this new project or new data set, they possibly will provide you the data dictionary, in which like you can have a look and understand like what are these For our case, because just we are starting and we want to know more and more functions in pandas to visualize. So if you see, now we have df.n unique. What it means, like how many like uniques are present in each columns. So now you see 891 passenger IDs. So all the passenger IDs are unique. Looks as if in survived column we have two values, unique values, which means 0 or 1, I guess. In P class I see three distinct values, means like and I know it is an integer, so it should be 1 2 3. All the names are different, all the genders are different. If it is 2 and the object, so possibly M and F. Then we have age and everything. Okay, let's move ahead. We got to know like how many unique combinations are there in each of the columns. Now we can see here we have info. So typically it does not provide any much information. Only thing is that like if you see there is one additional column, not null count. You see like how many nulls are there in, I think, in a particular column. So you see in each column possibly we have more number of nulls. In cabin we have more number of nulls. Okay, I'm also not sure of this field, but like seems as if like it is the one. Then we have something called index locator, and in pandas if I show you the data frame later on, yeah, let's say if I show you here, there's something like there are two concepts, like if we are talking about different rows in a data frame, the unique identity can be index, means like 0 1 2 3, or it is not necessary that you give it 0 1 2 3 only. 0 1 2 3 is a by default, but like you can give anything as an index if you're talking about rows. If you're talking about their like each row different features, that we call it columns, you know. So in like pandas we have two things like locator and iloc. Iloc means like index, locator based on index. It has more advantage. It is later on when we will talk about in some of the upcoming videos, like I will let you know like why this is a most unique way of filtering. So you know we go to 0 to 4, means like vertically we are going 0 to 4, 0 1 2 3, it typically means the same, and then horizontally we are going end to end. Okay, so that is how you see I have trimmed off a particular data frame, means like you can consider it by a scissor. Horizontally in terms of horizontally I have cut till fourth line, vertically I have not cut. Okay, so okay, now let's have a look at the lock as well. Lock is 0 5, means like vertically 5 rows. What is it? Okay, so now I see a different behavior here. 0 5 means like 0 1 2 3 4, typically you would expect this, and now but it has an extra line, but we will see later. Okay, the benefit of the lock, I told you like there are two things, index and column. So the filtering, the locator which is based on these columns is column based. So look, you see anything which comes between names and ticket, it take it out and includes both of these limits are inclusive. Here also we have seen, here also we have seen. Okay, then we have this locator. Of course,